Are we recording? Good morning. So a little bit of harmonics there. Who was here for the last talk? A couple people? Okay. So in the last talk, Kat was talking about how hams do things for fun. The history of this project, this actually started off as a one-credit research class for my bachelor's degree. If you think you've seen this in the Linux journal, you have. That was actually the result of my research project. So when I was graduating Eastern Michigan University, I was one credit short, and it's like, what do we do to do this? I want to find something that mixes ham radios with information security, so we came up with this project. So who am I? I'm just a guy. My name is Chris. I have a BS in Information Assurance from Eastern Michigan University. I have a OSWP, which is the Offensive Security Wireless Professional Certification. I've been doing wireless since 1998. Back when it was very expensive and cost prohibitive to do it. I think my company was one of the first ones to actually have wireless networks deployed, basically nationwide in all of our offices. I helped design the first wireless class for Henry Ford Community College up in Detroit, Michigan. The professor's like, I was taking the wireless class, or the wired class at the time. He's like, hey, you know a lot about networking. Do you know anything about wireless? I'm like, yeah, we run it at work. He's like, great, can you help us design the class? I'm like, sure, what do you need? He's like, we need labs. Okay, so here's 18 labs, and away it went. On top of that, I worked for GM as a contractor at a point. My job was to walk around the plants to go through and make sure there's no rogue access points. So that was my whole experience to war walking in 2005. I've got some scars from that, quite literally being ran over by robots. And then I do wireless site surveys and network design. Mostly I do more wired stuff now than I do wireless, but I still play with wires, or play with the wireless stuff. This talk wouldn't be possible without Larry Pesci, so I want to give a quick shout out to him. He did a similar project using Linksys routers, and it's really funny because when I started this project, I did my whole, anybody familiar with doing research in colleges and universities? You have to go through and do a whole documentation review, make sure that you're not redoing somebody else's work. So I'm searching Raspberry Pis and wireless intrusion detection, I'm finding nothing. And then when I'm going through troubleshooting on my Pis, I search for something else and I find Larry's gold paper. And it was able to get me past the parts where I was stuck at. So my document review failed, but the talk itself went forward. So why are you here? Anybody recognize the logo? Anybody? Somebody know it? Come on, security tools. I'm digging back to the 80s, come on. It's Tron. It's Tron's logo. So I'm assuming you're here because you like security tools, you have an interest in Raspberry Pis, and you like wireless networks. So the logos are from top to bottom because I don't like it when people put pictures in and don't at least credit it. Disney, Raspberry Pi Foundation, and the wireless network logo is from the Wi-Fi Standards Committee. So why do we do wireless scans? A couple of different reasons. The policy side, PCI DSS requires quarterly scans. It's the only, regulation's a hard word there, but it doesn't quite fit, but it's the only one that actually requires it. Nobody else does. HIPAA has rules for wireless, but it doesn't actually require wireless scans to find rogue access points. You can use it for data loss prevention. You don't have people coming in to just toss things on their network. You know, oh, I feel like I don't want to walk the mile between the plant floor and my office on the other side of the plant, so I'm just going to toss something in here and be done with it. That way I can just bring my laptop down here and work. Yeah, you want to make sure that's not happening because that gets left on at the end of the day, and somebody's sitting in the parking lot with a long-range antenna or a Yagi and directionally points to it and then just copies all your IP information. And then policy compliance. You know, does your company actually have wireless policies in place? That's the reasons for doing scans on the policy side. The other side, you want to verify your documentation, right? You walk into a new shop, you're the new guy on the floor. Oh yeah, here's all of our stuff. Okay, well, oh, I see we have wireless access points. And the documentation was put in place 5 years ago, but your access points were upgraded 2 years ago, and it doesn't have the right information. You can find interference problems before they become problems. So somebody next door, if you're in an office suite, comes along and does the same, you know, puts up their wireless network on the same channels as you. You can actually sit there and see the problems before your users start complaining about it. You can find interesting things like pineapples or Nokia phones. So, people like to drop tools in the office where they can come back later and say, hey, I've got this access point, I'm on your network now, I can dial in via cell phone or connect another way and do whatever I want you on your network. Lastly, you can find user problems, and this probably isn't what you're going to think what it is. Actually, last week I had a user call me wanting to open a consulting request for the department I'm in. He was having problems talking to the internet for the application he was writing. When he used his cell phone as a hotspot, it worked fine. When he connected it to the company network, it wouldn't work at all, and he couldn't figure out. The problem was that he wasn't pointing to the proxy, but if we were seeing that coming up and down, we could have went over and asked him sooner what he was doing before having him call, be a little bit more proactive, and actually help him fix his problem instead of spending a week trying to figure out exactly what he was trying to do. Real-time versus snapshots. So I mentioned PCI DSS, it requires quarterly snapshots, which is basically you just walk the plant floor, or you walk your building and collect whatever information is there. They're okay, but there's problems with that. You've got things that move. Basically, that's people plugging in and unplugging hotspots as they go through the building. You've got phobias and safety. I hate heights. I despise walking across rooftops. And that was one of the things I used to have to do. So I'm like 3 stories up, walking the edge of a rooftop of a building, trying to find a wireless access point. And then timing, but that's not what you think. Timing is, you go through doing your wireless scan at 8 o'clock in the morning when the majority of people are there, right? But you're missing the guy that's bringing a cell phone in at night, connecting that as a hotspot, and downloading torrents onto your company machines because he's bored on his job. So, real time, you'll catch that and it'll at least be in the logs and you can go back and view it. So the hardware specs for this project, this is the original Raspberry Pi B. So complete with all the bugs and faults in it. I use a TP-Link USB wireless card with an external antenna. There are actually 4 devices set up in the corners, collecting data right now. And then you have power, which is a couple of different options. In this case, we're running off battery. You can get power over Ethernet splitters if you want to put these in. The point of this talk is really to give you a proof of concept to take it back to your office and say, hey, this is what we can do cheaper. And if we need it, or if you're working in a small office, you can deploy these quickly and just collect your data and then be happy. I want to give you a quick cost comparison. Cisco, which is kind of the bigger name when you look at WDISs, these are based off of VAR numbers from last year versus the Raspberry Pi when I bought these last year. Actually, yeah, last May. So for Cisco, you need a service mobility engine. You can buy a virtual one for $3,000. You can buy a physical one for $4,500. Now, there's an asterisk next to that, and we'll explain that in a second. You need a wireless LAN controller, which is another $1,000. And then your access points, using the Cisco access points, is going to cost you between $164 and just over $1,000. Now, that's not taking into consideration your wired network for everything to talk back to, your switches, your routers. Raspberry Pi, I did it for Model B when they were still $35. You can get them much cheaper now, or you can get the newer versions. The wireless access card was $14.99. The power supplies were $9.99, and these are the plug-in 1.2 volt Raspberry Pi branded power supplies. And then the cases were $9, right? So we're talking at least $11,000 for the Cisco option. Raspberry Pi is $470. Just right there, that's a 4% of the cost. So if you want to do a proof of concept, you want to go through and show, hey, this is something we can do, then great, it's low cost. And this is for six devices. So when all is said and done, for 6 of the devices, it cost me $470 out of pocket. Now, remember that asterisk that keeps showing up everywhere? A wireless engineer I know at a large manufacturing company that makes automobiles in the Detroit area, he was quoted $20,000 just for the mobility engine, which now moves your price up to $32,000. So the VARs are selling it for one price, and if you're buying direct from Cisco, it's another price. And that was with supposedly with the company's 50% discount. So what am I running on these things? Like I said, I got 4 Raspberry Pis out deployed, and they're running Kali Linux. I went with Kali Linux for a reason. It had AeroDump already installed. Kismet was easy to install. But the biggest reason I went with it was the wireless adapter. I didn't need to compile drivers for it. So if I would have used that adapter on any of the other distros, I would have had to spend time compiling drivers, making images, running them around. I don't have tons of free time. I work full-time. I go to school full-time. So I went with, hey, I can just toss this on here. It's got an external antenna. Driver's already built in the Cali. I just need to install one tool, and I'm good to go. So Eastern Michigan University, when I first did this as my proof of concept deployment, this is what it looks like. You notice I've got 3 Raspberry Pis deployed. The scene by field is actually what I was trying to troubleshoot at the time. It has a 10-character limit. And we'll come back to that in a minute. But this is what it looked like on the EMU wireless network. So I have my Rogue Pi, which is actually in the room somewhere. You've got different plant secures, the school wireless, the school secured wireless, a couple of hidden SSIDs, and a bunch of data coming through on what's going on. And you can actually sort through these. But here's if anybody's wondering why I'm using Kismet and AeroDump, there is a reason for it, and this is it. I know the screen's a little small and hard to read. I'm sorry for that. There's just a lot of data on the screen. You've got the SSID, the BSSID, which is your MAC address. You've got, where'd my phone go? You've got 4 drones. Now it just says who it was seen by. It doesn't say who saw it last or who saw it with the most power. So if you actually want to track this device down, you'll know, depending on how big the deployment is, you'll know where things are based on what's seeing it, what's not. But if you've got multiple devices seeing it, you need to be able to zero that in better than that. Best way to do that, you've got AeroDump if you're locked into the single BSSID, and you look for the actual power. So this device is the furthest away with a negative 91, and the negative 71. This is in, I think this is dB. Yeah, dB. The negative 71 says that I'm closer. So my professor, what he did is he took my access point and hid it somewhere in the building, and as my proof of concept, I was supposed to find it. The original design is supposed to be four of these out running. Unfortunately, we only got 3. Then here we have the negative 59, which is the closest yet. This is a map of the building. Gives you an idea. It's not to scale. You can't see that I'm actually in a lab. So the lab partition wall is basically along here. And the laptop set up, I had drone in a window, drone in a window, drone in a window, drone next to a pop machine, actually, in the hallway. Drone 4, which was when I had the strongest power reading to it, was out in the hallway. And then we tracked the rogue access point down. Well, I know it's in this direction, so I'm just going to look up and down, top of the lockers, under the chairs. And I found it just outside the other lab, underneath the chair, which he had hid behind the chair leg. So proof of concept, yeah, it worked. It would have been nice to run 4 at that time, but it just didn't happen. Oh, my slides are out of order. So I mentioned that problem before. I've only got these 4, or these 10 characters I can use. So it's a little hard just to have everybody. So you're gonna have to go around and do a little bit of manual hunting. But let's hope I've actually placated the demo gods this time. Actually, we had problems getting them started this morning. This is what this room looks like right now. So I did an update on the drones last week. There's a couple of error messages in there. It can't set certain channels, but it's still working. So it looks like 2's not up and talking. I don't know if it's plugged in or not. I can sort this list. Has everybody played with Kismet in the past? Anybody not know how to play with Kismet? Okay, so I got 1 person, so it'll be useful for somebody. Right now it's set to auto fit. Let's go to BSSID. So different probes, conference room, couple hiddens, lobby. If everybody sees the rogue AP, let me know because there's a lot of text on the screen. But you get an idea of what you can see on the network, right? If you were to deploy this, I mean, this is a small space. Everything is within probably about 50 feet of each other. This talk is a trip hazard. I've got a bunch of cables up here on the podium with me. So I got a lot of choices. I'm looking for one specific one. I wonder if he's running that on his phone or if that's something else. There it is. So, didn't bring paper. Make this a little bit smaller for a second. Oh, Ryan's iPhone. So yeah, you can pick up different devices. You can pick up somebody, I don't know if Ryan's actually in the room or not. He's seen by three of the devices. But I'm interested in this one. It's seen by 1, 3, and I3, I5, and I4. And we'll talk about why I named them like that in a second. So let's go look at 13 first. And I keep checking my phone to see how I'm doing on time. I got plenty of time. So here's one of the bugs that has the Raspberry Pis. It's a little slow. There's a flaw in the firmware on how they handle their the network and the USB are on the same channel. It's actually the same bus. And there's a bug in the firmware and how it talks. So when you've got a lot of data pushing through, you lose connectivity to your Pis. The data is coming to me, but I know I'm dropping packets, and it takes longer to get into the Pis. Should be in memory. So it sees it -56, -58. Let's open another window. We'll connect this one to, can everybody see the numbers on the screen okay, or? Okay. Let's go into 14. So I have 2, 3, 4, and 5. You guys missed the 30-minute setup to put everything in place too. That was a lot of fun. I could have locked the channel, which I probably should have, but I don't remember if that was set to a channel hop or not. There we go. So I said 2, 3, 4, 5. I can't see the numbers on my Pis. Hey Jason, can you check the one in this corner and make sure it's 3?
Yeah, 3.
So I had that big screen before where I said everything was hard to see. This is the smaller version of it. It's telling me my access point name. It's telling me my VSSID. It's telling me what kind of access point it, or what kind of wireless signal it is. In this case, it's an access point. It tells me the encryption. I have no idea what the WPA for that is either. It tells me who's seen it, when they saw it last. See your point on my screen. It's telling me who's seen it, who saw it last. Like I said, that field that only has 10 characters. That's part of the reason why they're called I3, I4, I5. We jump back over here, -53. So he is at -53. I think this is going to be a case of where the size of the room is going to hurt us, but so 13, which is 3, 15, which is back there, and then 14. And I'm going back and forth between when I name the drones. The drones are actually called Drone 2, Drone 3, Drone 4, Drone 5. Drone 1 is actually set up as the access point right now. I keep calling them 13, 14, 15 because that's their IP addresses. I'm just weird that way. Anyways, I'm seeing the worst signal from the one that's probably closest to it because it's actually sitting behind Jason. But again, that's a case where the room is kind of hurting us too. And probably some of the material in the chairs and the flesh bags that are full of water, humans between the access point and that. If it was up higher, it'd probably work a little bit better, but live demo proof of concept. So how do I make these work and why do I call these drones? Kismet calls the remote access points drones. It's their naming, it's not mine. These don't fly around, they're not fancy that way. But let's look at the configuration for it. I don't need nano. Don't like nano anyways. So there's a lot of options in these that you can set up, right? If you actually see my article in the Linux Journal, I have a small, like 5-line snippet of the only things that actually need to be in here. But you've got new core version, which just tells you that's a newer one. The server name is Kismet Drone Pi 3, which is where the partial name of the i3, i4, i5 came from. It's telling it what interface to listen on for its TCP connection back to the server, which is running on the laptop. And then that's the port that it uses is 2502. So if you ever do a wireless, if you ever do an Nmap and you find something that's listed on 2502, there's a good chance it's running Kismet and acting as a drone. Not the only thing it's used for, but it's a good chance. In this case, the server is 65, and it's the only thing that's allowed to talk to it. Now, I can set this up to be any, I could set this up to be blank, I could set this up to be multiple servers. In this case, I just needed the one. Maximum 10 clients. I don't have GPS set up on this because I know where they're sitting, but if I wanted to, I could actually set GPS, add more power requirements to the Pis, and add more cost. So I set GPS to false because I don't even need to worry about it trying to hold the GPS configurations. Wireless source, it's the ATH5Ks, which replace the MAD Wi-Fis. And last thing is what channels you listen to. US, BK in this case. So your B, your G, half of N. I've actually got A commented out, which would be the other half. And then you have a combo list. And then 4 is the same way. And it's not in the Kismet file because that's for server side. It's actually in the drone file. So if you ever install Kismet, you see the 2 different files. That's why they're there. One's set up a Kismet server. The other one's set up for Kismet drone. Sorry I don't talk when I type. It's just the way I am. So I know there's long pauses while I'm typing. So like I said, the ATH5K pretty much replaced the MAD Wi-Fi. But again, we see GPS is false. We see our capture source, channel settings, GPS back up here at the top. Again, the allowed host. This actually needs to be there so it can talk to itself, the drone allowed host, which actually starts the server. And what happens is I've got these actually turned into daemon mode. So as soon as I plug the power in and these things finish booting, it's already pushing data back to the server. So PSX. Here's all the running daemons. In this case, I set it up to run as a daemon on boot. And I'm trying to remember where that's at. I don't remember. It's in the Raspberry Pi documentation. It's easy to find though. Basically, this if you're using a Raspberry Pi, just look up start on boot, and you'll find where you can set things up to start that way. So that's what the drones look like. Shut this one down. Let's look at the configuration for the server real fast. I updated these things last weekend and didn't realize that the error came in because that wasn't like that before. So that's new and I just haven't had time to troubleshoot it. You know, job, school, rest of life. Anybody else have problems not finding enough time to work on things they want to because they have other things they have to do? So my Kismet configuration for the server, it's a little bit newer version of Kismet. Here's the main thing that you're going to change. Normally when you set these up, you have your sources, right? Well, in this case, you're changing your source to the source, and then it's drone. You put the host IP address of the drone in, which is why everything is static IP'd. The port number to listen to, so you can change the port numbers if you really want to. All the documentation defaults to 2502. Here's where I set the name. You know, I only have 10 characters I can display in that one screen. So it's like, I can put whatever I want into here, but if I want it to be useful to me, I need something really short so I can see everything I have. If you notice, I've got one more drone I can deploy at 6. It's kind of my backup when something fails device. And it's commented out so it just doesn't sit there and try and connect and throw errors. Again, I don't need GPS. Trying to see if there's anything else in here. But the source is your main thing that you need to set up. I don't know if commenting those out would actually fix that error problem with the channel list. Like I said, I haven't had time to troubleshoot it. Copy the drone configurations if you want to run a drone and a server on the same thing. Yeah, that's pretty much anything. Is the what? Yeah, scroll back up. Yes. Oh, the OU file access? I'm not sure, to be honest. There's only certain parts of Kismet I've ever looked at. And I've been using Kismet since 2005 because it's one of the tools I used when I was at General Motors. But there's a lot of Kismet that I've never dove into. I've only dove into the parts I actually needed, and I haven't looked beyond that. So, I actually couldn't tell you what the OU files are, or the OUI files. But the big thing there that I wanted to show you was the setup for the drones and how to get the drones talking to the server. Let's go shut down the last two. And now we'll see if 2 is actually powered up or not. Okay, so for whatever reason, 2 is not actually working. Which makes turning it on easier. So back to the slide deck. Live demo wasn't horrible. I get to talk about the configuration files and show them to you live. There are some limitations. I mentioned it several times now. The hard code to 10 characters. Again, that's what allowed me to find Larry's paper. He did the same thing using the old Linksys wireless routers. Flashed the firmware and deployed them in the same way. So finding that helped me troubleshoot the problem I was having with the 10 character limit. Kismet's network view only shows the strongest signal, not all 3. So I don't have the ability to go and say, oh, it's closest to this one, and send somebody out there to take it for policy reasons or go investigate it personally or whatever. To work around that, that's why I have AeroDump installed and why I'm using the AeroDump, just to get the power locations and moving around. Hardware limitations. The wireless cards I used, I bought them because they were known to work and they were cheap. They only do 802.11b, G, and N, and they only do half of N. It doesn't do Bluetooth, it doesn't do Zigbee, and it doesn't do cellular, which I've actually been asked in other presentations of this, like earlier presentations, can we deploy this on a plant floor and we'll pick up the cell phone? Can we deploy this on the plant floor and we'll do this? Well, can we do that? Can we, you know, we're worried about people bringing stuff in and beyond just wireless. And it's like, no, it can't. System failure. So other than two crapping out on us tonight or this morning, as I mentioned, the USB has a known bug because of in the firmware. I've got a B+ and I've got a Pi 2. I've got them configured. I have not been able to put them into a target-rich environment. So what happened was I went to a place where, when I was doing a presentation, set everything up, and I was really happy, and I was like, I'm going to rock this presentation. It's going to be the best presentation I ever gave. And then I couldn't talk to any of the devices because there was more access points there than there were here. And nothing would talk back to me. So I was getting the data, and I could see packets being dropped into the error logs, but I couldn't actually SSH to anything to show the here's how you hunt things down. And that goes back to the bug in the firmware. I did firmware updates on all these guys last week, except for 5, and it's still slow to connect. So apparently that wasn't fixed in firmware for the older Pis. And when I tried testing the B and the B+ and the 2 this week, I think it was Tuesday, there's no power in the cafeteria to test it. Because I happen to be back in that building, and it's like, ooh, hey, while I'm here, pull these out. There's nowhere to plug in at. Future things I do want to test. I want to try this with a Ubertooth. I think it'd be pretty neat. I know it'll work with Kismet. I just want to see how it'll work, what it'll do, will it work, can I make it work? Has anybody heard of the Kisbees? Okay, so it's being designed by Draghorn, the same guy that designed Kismet. It's designed to do Kismet for the Zigbee devices. It's kind of in development now. I talked to him at DerbyCon last year, and he's like, yeah, I've got somebody I'm talking to for the hardware portion, but it's a timing issue, just no time to work on stuff. And then this is actually how I found out about the bug to begin with the firmware. I was talking to Zero Chaos. Does anybody know that name? I see a couple heads nodding. Works on the Pin 2 distro and does a lot of wireless testing. We were talking about this, and I was like, yeah, so I want to get one of these hack RFs and see how that works with Raspberry Pi. I was like, oh, it won't run on Raspberry Pi because of this problem with the firmware and blah, blah, blah. And then we'll go back, and I started finding that. It's like, well, that's why I couldn't talk to things. So eventually I want to get all 3 of these, test them out, maybe change out the monitoring software, do software-defined radio instead. That way I get a larger spectrum of what I can see. Because wireless networks, Wi-Fi is in one section of 802.11, then another section of the band is your Zigbees, and then another section is your Bluetooth. So I think Bluetooth is 802.15. But it's all still part of that ISM band that Kat was talking about in the last presentation. So thank you for coming out. I also want to say thank you to Stephen Fox and Jen Fox last night for helping with the slide deck. The slide deck was a complete mess, and they came up to the room last night and helped us out. Questions? Yes?
Have you automated any of the detection capabilities? Anything that in the work environment generally the hotspot or Wi-Fi access points are fairly static, consistent. So if the new one pops up, you have automation that you know it's going to go.
There's options in Kismet to do that. I actually haven't looked at that because for the class it was 1 credit hour and proof of concept. I was more worried about graduation, and I've been working on other things besides this since then. I do know that there is abilities to send emails when new ones pop up. You can also, if you've got a up-to-date documentation, you can put the BSS IDs in to Kismet to say ignore these, so they don't show up in the list. So you only see them when new things pop up, and you'll get an email to it. I do know when Linux Journal, so this article was originally published in December. In February, they put it on their website, so if you want to go read it for free, you can. Person made a comment saying it'd be really useful to add this to a SIM. I've done SIM work in the past, but I haven't ever tried adding alerts to a SIM. So I don't know if there's certain documentation or certain ways to do that too, so it would be automated part of the SIM. That might be what the OUIs are for. One of those things I haven't looked into because I haven't had to do it before. Yeah.
Maybe this was discussed early on. I apologize if it came in a little bit late. Could this be modified to look specifically for like client MAC addresses? So like if you had a person that came in with a cell phone, for example,
Yeah, so the question is, can this be modified to look for clients? I don't have the picture with me, I wish I did. For Halloween, I dressed up in a suit and a ski mask and put a white hat on top, a white derby, because I was being a corporate hacker. But what I had next to me, and this is why I wish I had the picture, what I had next to me was a 24-inch monitor with a Raspberry Pi taped to the back of it, running, showing all the clients as people were walking up. So as they walked up, their cell phone would pop up. I did analysis on that later, and it's like, oh, so this guy has been at all these different all these different locations because it's beaconing out. Who here knows how Wi-Fi on a cell phone works? Got a couple hands? Okay, so when your Wi-Fi is on, it constantly beacons until it connects. So every place you've been and it has saved in its memory, it tries to connect to. So I'm seeing hotels, I'm seeing restaurants, expensive restaurants. It's like, this guy's got something shady going on. Wait, these are kids. Why are they going to hotels and expensive restaurants? I'm pretty sure it was their parents that were sitting at the sidewalk. So yes, if you go into, and I wish I actually had something still up now because I could actually show that. So we were looking at the access point list, but there's a whole other section that's clients, and you can actually go look at the client list instead.
There's some interesting stuff that going on around retail where they just want to tell what people are spending most of the time.
Yep.
They can tell, hey, this factory spent so many minutes over here, or only one here that left, or
One thing I do want to mention about Aerodome on top of that, though. So you brought up a good point about the retail stuff and tracking you through a mall. And everybody here has heard about the hotel in Tennessee that got busted by the FCC for blocking people's cell phones. You can do that with Aerodome too, and that's actually a built-in feature to Cisco's and Motorola's and a couple of the other WIDS's. If this isn't part of my network, kill it. And it just sits there and does constant de-auths. You can do that by hand with Aerodome too, but I didn't cover that part because I don't want to get fined by the FCC. But so there's more features here than what I've mentioned. But like I said, this is your basic proof of concept, small business type thing. If you want bigger, and you use this to get the funding for something later. Hey, look what I learned at CircleCityCon. Set it up real fast, show what's in your building. We need to have this because of this.
My obvious thought process, or what have you, was is that can you take a Raspberry Pi or similar device, maybe wire it up with some sort of output, so if you're looking for a specific MAC address, maybe the boss or something showing up at work, as soon as they come within that, obviously it lights up or something, kind of an early detection system.
So you could. You'll have to deploy a lot of these, or at least have them deployed by the door. The antennas have a 300-foot range. So like I said, smaller room. I've got 100-foot cables and 50-foot cables spread out right now. If I had longer cables, I can spread them out further. And then the antennas themselves, because they're externals, go up to about 300 feet. So yeah, if you want to know if he's within 300 feet of you, you could do that.
My personal space.
Yeah. Yeah. Any other questions? Again, thank you for coming out. I hope it was at least entertaining to a point, and you can take something back to your office and do something good with it. One last thing. I don't know if anybody's seen the tweets. I don't know if anybody read the Tripwire article. But if you can find me in a open area, meaning I'm not in a class, and I've only got 2 scheduled for this weekend, I will be happy to help you set these up if you brought the hardware. So, because that was, I gave this talk at a lug. The guy came up to me afterwards, like, "Can I get your card so I can ping you with questions later?" It's like, okay. When I put the presentation in, they said this would work great as a training class, but then somebody else set up a Raspberry Pi training class. I was like, whatever. I'll see it by the bar. And if you guys have the hardware, track me down and I'll help you set it up. Thanks.